Hello. In this video, we study related rates and we will use related rates to solve some real-life problems. We know differentiation rules, especially the chain rule. It says if you have function y as a composite function of f and g, such that y is f of gx, then the derivative of y is the derivative of f evaluated at the g times the derivative at g. And we know that the chain rule says, yeah, you need to find the rate of change, right, of the function y. So then you just need to find the rate of change of the outside function evaluated at the inside and multiply with the rate of change of the inside function. And if you look at the product rule, right, so you have y equal to f times g. You see, you have f prime is what? Is f prime g plus g f g prime. So both formulas right here gives you some relation between the rate of change of the function y, right, depending on the rate of change of functions f and g. Is it correct? So a related rates, right? In this topic, we will consider how race depends on other race. Okay, let's consider this example. You have a conical tank of water, and then you drain it out. Okay, you drain it out from here, and suppose that the base of this cone has radius equal to r. Of course, that is a circle, and the height is h. So we know that the volume of this conical tank can be found using this formula: V equal to pi over 3 times r squared times h. And let's say we drain the water out, right? So we want to measure the level of water or the volume of water remaining in the tank. So it says each time, when the level of water decrease, right, the radius, the corresponding radius also decrease. Is it correct? Because you cannot use the same radius to find the volume of waters, right? So we see that r and h actually are two functions, right? Are functions in the time t. Is it correct? So I can write rt and ht. Then v is also a function depending on t, right? rt squared plus times at. Okay. So if you want to find the rate of change, how the volume will change depending on the changing, depending on how RT and HT change, right? So you just need to find the derivative of V. So we find the derivative of V in T is pi over 3. And you take the derivative of R, right? You use the product rule because you have two functions in here. So I have 2 times RT times R prime times ht. That is, the first term. This is the derivative of rt, because we need to use the chain rule, right? Plus pi over 3 rt squared times h prime t. So this formula shows you how the volume, the rate of change in the volume depends on the rate of change of the radius and the height. Okay, so that is just an example how we can consider related rates, right? All right, let's consider the following example. Let's consider the following example. We have two functions x and y, two variables, and both are differentiable functions of t, where t is the time, okay? And they are related by the equation y equal to x squared plus 3. you see that, yeah, that is parabola, right? But sometimes we can parameterize x and y as functions in one variable, in another variable. So let's say in t, okay? And they ask us to find the rate of change of y in t when x equal to 1, given that the rate of change of x when x equal to 1 is 2. Okay, so if they ask us to find the rate of change, the derivative of y with respect to the t, so you need to find the derivative, right? You differentiate the equation y equal to x squared plus 3, but in t. Usually I write in t like this. Is that correct? So when you differentiate that, you add dy dt in here, and then since x is a function of t, so I need to use the chain rule, right? So I have 2 times x times dx dt, means x prime. Derivative of 3 is 0. And I can use this, right? Because they ask us to find the rate of change of y in t when x equal to 1. You see, x equal to 1. So I have x already, x equal to 1. And then I have the rate of change of x with respect to t, right? At that time. So when x equal to 1. So I have this 2. From here I just plug everything into this to find dy with respect to dt is 2 times 1 times 2, which is 4. You see, it's pretty interesting and pretty easy, right? But of course, if we understand everything, we understand, the meaning of differentiation rules and the meaning, the situation, right? Let's say the situation. So you have parabola y equal to x squared plus 3, but at the same time, x and y are parameterized as functions of t. You see, as function of t. So, we need to use, raising here. Is that correct? And when you differentiate both sides of this equation, you need to differentiate in t. Okay? So there's no way to get, 2x in here. Does that make sense? Because x is a function of t. Let's consider the following example. I think that, maybe any of you would play this game when you were a child. So suppose that you have a pond, right? And you drop it, just a rock, right, into a pond, and you can see, yeah, that rock cause ripples, right, in the form of concentric circle. So this is the position of your rock, right? So you have circle. The circle, of course, move from the inside, and far from the center. So that means the radius also change, right? If the radius change, then the area of those circles also change because the area is pi r squared. Okay? And they give us that the radius of the outer ripple is increasing at a constant rate of 1 foot per second. So it seems like, the radius and the area are functions of t, where t is the time. Is that correct? So I'm mentioning here a and r are functions of t, okay? And the question is, when the radius is 4 feet, at what rate is the total area A of the distilled water changing? So they ask us about the rate of change of the area function. Okay, so you see, when you read this problem, it seems to be complicated, right? But if you rewrite this in the mathematical language like this, so it looks simpler, right? They ask us to find the rate of change of A when r is equal to 4 feet. And given that the rate of change of the radius is 1 foot per second, right? Because that is constant. So, it's pretty easy. You need to find the derivative of A, right, of the area function. So, You differentiate this equation, you get dA over dt equal to pi 2 r times r prime, because r is a function of t, right? And then you just plug r, they give you r right here, they give you the r prime right here, so you are good. You have pi 2 times 4 times 1, is it? And you have 8 pi. So 8 pi is the rate of change of the area when r is equal to 4 feet, and with the condition that the rate of change of the radius is constant. Okay? So after two examples, we may have the following guidelines for solving related rate problems. Now, firstly, we need to identify all given quantities and quantities to be determined, right? And then we need to write an equation involving the variables. For example, in the previous example, we have the A equal to pi r squared, right? And in the very first example, we have the volume right here, V, depending on R and H, right? And in the second problem, we have y equal to x squared plus 3. You see that? And then the next step is we need to use the differentiation rule. In this case, we use the chain rule and implicitly differentiate both sides of the equation with respect to the t, where t is the time. Okay, in real life, of course, as we have seen here, t is the time. So the area function is the function depending on t. The radius also depends on t, right? And in here, you have function x and y also depends on t, because x and y are parameterized as function of t, right? And in very first example in here, where you have volume depends on t, you see? And then the last, so you differentiate both sides, right? You get what you need in here, all rates, right? All rates of change. And then you not, the last step is just plug everything they give you, right? Substitute everything into the equation after differentiation, and you solve for the required rate of change. Is that correct? So you see, actually when you see a real world problems, you need to read problems carefully and try to get information from the problem. And I think that is the most difficult part, in my opinion. But once you already get enough information like this, so you see, it's pretty easy, right? The solution is pretty easy. So in order to finish this video, let's consider the following example. And we'll do all steps like in the guidelines, okay? An airplane is flying on a flight path that will take it directly over a radar tracking station. So we have radar tracking station right here. This is our airplane, okay? So the airplane is flying in this direction, okay? And the height is 6 miles. S is the distance from airplane to the radar station, okay? The first step is we need to determine quantities they give us, right? So what kind of information we have? We know that the S is 10 miles. So S 10 miles. I mean that is the moment when S is 10 miles, right? And at that moment the rate of change of the distance S is 400 per hour. So at this time, the rate of change is 400, right? Miles per hour. Okay. What is the next? We know the distance right here, let's say H is equal to 6 miles, okay? I think that's it. And they ask us, what do they ask us? They ask us, what is the speed of the plane? So the speed is right here. Is that correct? The speed of the plane means okay, so we have speed in here, right? Because we don't have anything. They ask us about the speed. of the plane. So that's all we know, right? And all we need to find. So since they ask us about the speed, I need to make, to measure, right, some distance in here, because without the distance we cannot find the speed. Is that correct? So let me denote this by the distance from the airplane to this point is x. Okay, is x. So that means, let's say we need to find x prime, right? X prime in t. Okay, so that is the first step. We finished that. We list all quantities they give us and the quantity to be determined. Second step, we need to write some equation. So we need to find equations from the problem, right? And from the picture right here. And if you use Pythagorean theorem, you have the following equation. S squared equal to 6 squared plus x squared. Is that correct? So of course, I can write st squared, right? Equal to 6 squared plus xt squared, because x and s are functions in t. Okay, so we finished the second step. Now we need to differentiate both sides of the equation using the chain rule. Is that correct? So that is the third step. I differentiate both sides of this equation. I get 2 st times s prime equal to 0, because 6 squared is just constant. 2x t x prime t. Is that correct? So what do you have in this case? I might simplify, 2. So I have the following equation. St times s prime t equal to xt times x prime t. All right, and now we need to determine the speed of the plane. That means the x prime with respect to the t. Is that correct? So I just solve this by x prime. I get st times s prime t divided by xt. Now look at this. We have st, because s at that time is 10 miles right here. So I have 10. We have s prime. S prime is 400 miles, right, per hour. But of course s is decreasing, so I would write the negative over there. Okay, I would write negative over there. Negative 400 and divide by x, right? By x. How to find x at this moment? Of course, we can find the x because we know s is 10 miles, right? So when s is 10, x should be equal to 10 squared minus 6 squared. We just use this equation. Again, Pythagorean theorem, right? So this is equal to 100 minus 36, which is 64. That is x squared. So from here you get, x is equal to 8. All right, so I plug 8 in here. I get what I need. The answer is negative 500 miles per hour. You see, I'll tell you this. It is pretty simple in mathematics. But again, right, as I mentioned previously, the most important part is the first 2 steps right here. This is the most difficult part. We need to get information from the problem they give us. We need to determine quantity that we need to find. And then we need to recognize, we need to recognize the equation. Okay, so I know that this topic is difficult, and you have plenty of problems in the textbook and on website. Please practice a little bit. Okay, and I hope that you feel more confident in such problem. So we finish the chapter in here. We'll do a short review, and we will write test on this differentiation rule. Thank you.